When the Big Bang expelled a lot of hydrogen into the galaxy, it took quite a long time for stars to get made, but when those stars did get made, lots of new interesting elements were created due to the stars doing interesting things, like supernovaing, and also doing fusion to create new combinations of electrons, neutrons, and protons. When those combos had the same amount of all those things, you have a stable atom of some kind. When there were extra neutrons, those neutrons would periodically break off the atom, and that created energy. This is called a half-life. The Earth's core is lots and lots of these unstable atoms, and the energy that they've been releasing has been heating Earth's core for the last 5 billion years. The source of geothermal energy will be available long after the Earth is no longer habitable, but actually harvesting this constant source of energy can prove to be difficult. The world's oldest use of geothermal energy was a hot spring bath in China, where magma got really close to the surface and heated up some pools. Geothermal energy for use in heating is a really big thing in Iceland, where you just warm up some air below ground and then bring it back up to provide a cheap source of heat in the winter. But as useful as this is, it doesn't provide an easy source of electricity. You can't just turn heat directly into electricity, you need to spin around a thing really fast so that it produces electricity. This is called a turbine, and although we have improved turbines themselves and made them more efficient, we haven't yet found a better way to generate electricity than from using a turbine. A strategy that early geothermal plants used was to pipe condensed but really hot water into a chamber with a turbine in it, then release that pressure and let the water turn into steam instantly. This was called the flash steam power plant, and they're still being used today. But this only works in places where there are hot spots that can heat water up to over 180 degrees Celsius, and most places don't reach such high temperatures without some really deep and expensive tunnels. In the late 60s, the Soviets developed the binary cycle power plants, which use a second fluid to run the actual turbines. They pipe hot water up from underground, and they run that water next to an organic fluid with a really low boiling point. The fluid, something like butane or hydrocarbon, heats up really fast, much like in the flash steam plants, and is funneled into a turbine to generate electricity. The water goes back underground to reheat, and the working fluid is reused once it passes through the turbine and is recondensed. Most places that have hot water and naturally formed aquifers are really rare, so something called EGS, or Enhanced Geothermal Systems, was invented in order to create pools of hot water underground for the power plant to use. In order to do this, they drill a hole into the ground until they reach the designated depth. This can range from 0.5 kilometer to 4.5 kilometers, and it depends on the stability of the land in that area and the temperature that they need their water to reach. Once they drill the hole, they inject large amounts of pressurized water into the newly named injection well and create fractures in the rock. This creates a reservoir of underground water for whatever the geothermal power plant needs it for. Water is pumped down the injection well and it absorbs the heat from the rock that it passes through before it goes to the surface to do turbine things. This process can cause a lot of problems, such as minor seismic activity or small earthquakes. Drilling holes in the ground releases various gases that can cause acid rain and contribute to global warming, so the people drilling have to contain those gases. There is also a chance that an underground reservoir could become structurally unstable and collapse, causing a sinkhole in the surface. Most of these problems cease to exist once the injections are done, but occasionally they do prove to be trouble. A major geothermal power plant in the Philippines was cancelled because the injections were destabilizing the area and causing problems with land sinkage. The main roadblock with geothermal energy, however, is economics. Upfront costs are high, and the plant has to generate enough electricity with decently low costs in order for geothermal energy to be cheaper than fossil fuel energy. Locations are usually best located near faults in the tectonic plates, where there are more hot spots and the heat is easier to get to. Many large plants are constructed in that type of area, such as the geysers in California or many of the plants in the Philippines. Geothermal energy is a scalable, clean, and easily accessible energy source that provides yet another option when considering fossil fuel replacement. Also, it saves many people lots of money in terms of simple heating, which can help cross yet another item off the carbon neutral list.